Geometric sequences. So we've just been looking at arithmetic sequences where everything was going up by a common difference, going up or going down. Geometric sequence has a common ratio, and a common ratio is made by multiplying the previous term by a fixed number. So if you have a look at this example here, you can see that to go from 2 to 6, you multiply by 3. 6 to 18, you multiply by 3. So for each of the following numbers, we are multiplying by 3. So therefore, our common ratio is 3, the number we are multiplying by. It also works that if you go backwards, you are dividing by 3, but your common ratio is always going to be 3. So our common ratio R is any term divided by its previous term. Looking at the example here, the question is asking which of the following are geometric sequences, and then if it is a geometric sequence, find the common ratio and the fifth term. So if we can find a common ratio for each of the terms, then we can therefore say it is a geometric sequence. We can see that for each of those terms, when they're divided by their previous term, the answer is 5. So therefore, our common ratio R is equal to 5. And because it's a geometric sequence, therefore we're going to multiply 250 by 5, which gives us 1,250. Have a look at the terminology there that we've used for the fifth term. T5 is the best way to write that. So R is the common ratio, T5 is the fifth term. Looking at the next one there, so again, we're looking for the same thing. We can see that 6 divided by 3 is 2, but 18 divided by 6 is 3, 36 divided by 18 is 2. Because one of them is out, therefore it is not a geometric sequence. And if it's not a geometric sequence, then we can't find the fifth term for it. In class, we'll go through how to generate a geometric sequence on our CAS calculator. It's not unlike generating a arithmetic sequence, except we're multiplying this time rather than adding or subtracting. So this is a pretty important bit of information here. Our common ratio R is always a value bigger than 0. Never 0, always bigger than 0. Now, if it's bigger than 1, then it's going to produce a graph that is increasing. If our R value is between 0 and 1, which means that it's actually going to be a fraction, then it produces a graph that is decreasing. Something to keep in mind. Let's look at this example here. Considering the geometric sequence, well, we are told that it is geometric, and so let's find what R is straight away. So 16 divided by 32 is equal to 8 divided by 16. So our R value is 1/2. We also know, because R is between 0 and 1, that our graph of that would be a decreasing, and we can see that our sequence is getting smaller. So find the next term, which would be term 4, and of course it's going to be 8 times 1/2, which is 4. And putting all of those values into a table showing their position and value looks like that. Term up on one column, value on the other, and then fill it in. So this part 3 asks us to use the table that we've just plotted to draw the graph. Very important here that we put the term on the horizontal axis, the value goes on the vertical axis. And it's also very important that we use a scale. So on the vertical axis, I've gone up in 4s because that obviously suits the data that we've got. Now, if I use the values that we have got, I know that T1 was equal to 32, T2 was equal to 16, T3 was equal to 8, T4 was equal to 4. Now, that's what our graph looks like. Hopefully you can see that that's a decreasing curve. Although we would never join the actual points together, I'm just going to show you in a different colour what that graph is looking like. Now remember, we knew that R was equal to a half, so we're going to get a decrease, and that is what we are getting. It is not straight line. So in part 4, where it's asking us to now describe the graph, for the graph with R equal to a half, you can see that it is a decreasing curve, and as the terms get larger, the values get smaller. So that is how we would go about describing that graph. It is a decreasing curve. We always include our R value, and we talk about it in terms of term and value.